Good morning, everyone. Welcome to the latest session in our Siemon TechTalk series. Thank you very much for joining us today. My name is Christopher Homewood, Marketing Manager for Europe, Russia and Central Asia at the Siemon Company, and I'm excited to be joined today by my colleague Lee Funnell, Technical Services Manager for Europe, Russia and Central Asia, and Felix Knight, Technical Director for our AV partners, Lightware Engineering. In today's session, Lee and Felix will take a deep dive into AV over IP, exploring the key drivers for this technology and how the introduction of applications like SDVoE is opening up greater possibilities and benefits, allowing users to move away from traditional siloed AV architectures and deploy their solutions onto their network cabling infrastructures. If you have any questions during the session, please enter them into the panel provided on the right-hand side, and we will have a short Q&A session at the end to discuss them. Excellent. Lee, Felix, over to you.
Hi guys, good morning. Thank you very much for taking time out of your day to be able to attend this session, which I hope you're going to find very beneficial. Thank you, Chris, for the introduction. For those who don't know, my name's Lee, and as Chris said, I look after our technical division, looking after Europe, Central Asia and Russia. So the agenda today, we're just going to give you a quick introduction about Siemon, something about Lightware, introduction of Lightware from Felix, and then we're going to sort of jump into AV over IP, and Felix and I will be, sort of sharing slides and discussing amongst ourselves as we discuss with you. So please make sure that you put any questions into the chat box, as Chris mentioned, because that's a really important part of what we're trying to do. So a brief history about Siemon. So Siemon is a structured cabling manufacturer. We have our global headquarters, and that's based in Connecticut in North America. And our European footprint is pretty large. We have lots of global regions, but for us today, this is our European footprint, and it's a pretty vast expanse of countries and demographics that we look after. And then in terms of our global footprint, we are truly global. And it's quite interesting that many companies promote themselves as being global, but they don't have partnerships with distribution channels in place. And Siemon, we have all of that in place. And in order to support that, we sort of operate in over 40 countries. And then we have an additional regional and support offices and an additional 40 offices. And we have 7 manufacturing and warehouse sites around the world, plus our distribution partners holding Siemon stock. So we're exceptionally well covered in terms of logistics and getting products to our clients, and also offering our rather unique services and support. So our company structure, we're a very stable company. We are a family-owned business with 4 generations, and we're still going strong. In fact, this year, I'm really sort of quite in awe that the Siemon company has been operating for 118 years, and 117 of those have been in the telecommunications industry. And this really does make us the oldest family-owned telecommunications company in the world, still privately owned. One of the most interesting things about us is the fact that we are a very flat organization. That means that as customers, you can gain access to our senior management team very, very quickly if you have any questions or you need help or assistance. But because of that, that means that we're very responsive, we're very agile, and we don't have a lot of the bureaucracy that lots of other sort of companies have. Now, right at the beginning, I mentioned that we're 4th generation, still going strong. Carl Siemon is stepping down in January, and he's handing over to our new CEO, which is Henry Siemon. Henry will be taking us forward for the next many, many years as Siemon continues to grow and develop new products to support the industry. So really exciting times at Siemon. What was really interesting with Siemon is we do a lot of work with what we call complementary manufacturers, such as Lightware. And it's really important for us in terms of talking about intelligent buildings that we really understand, that we are working with the best companies to be able to support our customers. And what was really interesting was when we started talking with Lightware and going through our complementary manufacturer approval process, we actually found out that Siemon and Lightware actually have many joint customers, and these aren't small customers, these are very large businesses. So it really sort of builds confidence in Siemon and with Lightware that our joint partnership is working well together, because we're supporting the same sort of customers, and these aren't small businesses. So a lot of success for both Lightware and Siemon there. I'll hand you over to Felix now for a quick introduction about Lightware.
Thanks, Lee. Yeah, so many of you might not be totally familiar with Lightware, so I'll just go through a short introduction piece. If I do this. Yeah, so about Lightware, the headquarters is located in Budapest in Hungary, and then we have a coverage of 30+ countries. We've got 18 Lightware dedicated offices in different regions, and then other areas are covered by distribution. And taking a closer look at the headquarters, everything is designed and manufactured within one building in Budapest, which is a really nice way to work. It's very good to have everyone in one building. If there's any questions or investigations into products or developments, you can always find the right person in the building. Unfortunately, due to COVID, we've got a lot more people working from home, but hopefully we'll be able to get back to that way of working soon. About the Lightware team, in the headquarters, we've got just over 200 employees, and 50% are working on product development and working as developers, and 70% of all the employees are engineers. So everyone, there's a strong engineering background, and it's a very engineering focused company. Just a brief look at some of the history of Lightware as a manufacturer. I'm not going to go into all of these different milestones, but what I hope you can see is that we focus on developing world's first products that other people haven't made for technically challenging reasons. If there's an engineering problem that other people find difficult to solve, we like to use our engineering resources to provide that solution and sort of break new ground in the AV market. So just touching on some of the sort of focus points of Lightware, I guess we have the open API, analytics and diagnostics, pioneering technologies, and reliability. These are all core Lightware principles. The technologies, primarily we are using HDMI signals. In the beginning it was DVI. Oh, sorry, I'm getting a bit of a difficulty here. Here we go. So yes, a lot of our products have an HDMI backplane or backbone. This is the evolution from DVI. On an electrical level, we're talking about TMDS signals. We also produced a lot of HDBaseT products, which were extending over Cat cables, primarily Cat6a. And then we also have a large range of fiber optic products on both single mode and multi-mode fiber. And this is what I would class as the traditional AV stuff. We also have AV over IP, which we can touch on in a bit. Zero frame delay and instant switching are also key sort of design philosophies. Lightware really got its break originally in the live events market, where having frame delay or taking a long time to perform a video switch were sort of big issues that influenced the design. So those principles have stuck through all the products that we make. Obviously with AV over IP, some of these things are going to introduce some delay, but it's always our goal to keep that as a minimum. HDCP compatibility is a problem in AV systems with HDMI devices, particularly in larger deployments. And we've always been on top of HDCP. We actually introduced a lot of features that became standardized throughout the industry, particularly being able to disable HDCP on an input. So we're not talking about stripping it out and breaking the HDCP rules. We're talking about being able to control what gets reported as compatible and incompatible. Pixel accurate clocking is another Lightware proprietary technology. It's really designed for larger systems. So in a simple system like this, you might not need the benefit of pixel accurate clocking. But if we were to expand this and add in different boxes and different sort of jumps between the different devices, each one of those devices and copper-to-copper connections, long cable runs, they can degrade the quality of the video signal, sometimes to the point that it can't be recovered. And what pixel accurate reclocking does is recover the signal to the same quality or the same specification as when it leaves the source device. Yeah, I can go into more about this, but perhaps another time. Advanced EDID management has also always been a core Lightware feature. For a long time, we stayed away from scaling technologies because they would add latency, and also because with correct EDID management, we feel that you can sort of dictate to your source devices which formats, which resolutions you want them to use. And yeah, we can go into a lot of detail into EDID, which is, in my opinion, a very core part of designing your AV system. The open API is another sort of choice we've made to focus on what we're good at, which is the video infrastructure and you know, sending different signals around, and leave ourselves open to working with other third parties, whether that's different hardware manufacturers or different softwares. Having an open API has been really beneficial, and it means, you know, there's different aspects of our control protocol which really lend themselves to working with other third-party systems. You know, we're going to specialize on our part, and we leave ourselves open to working with other partners who have their own specialty. We have our Lightware device controller software. It's one software that controls every Lightware device, so it works with everything that you can connect to. Just to give a little overview of what you can do with it, you've got a lot of diagnostic information. Here we've got the frame detector, which is sort of a physical measurement of your video signal, and you can use that to measure the integrity of your signal, whether it's stable or not. We also have our TPS or HD-based cable diagnostics. We were one of the first manufacturers to actually present this information back to the user. The HD-based chip itself has registers for different error rates and cable quality measurements, and this is very handy if you are working on a deployment and you've got something like your picture dropping out. Being able to get this diagnostic information is really helpful. When everything's working fine, no one really cares about this information, but when you have a problem, it's really critical to have this. And yeah, going back to some of the customers that we've worked with over our history and some of the sort of end user relationships we try to manage, we can take a look at some of these. So with Accenture, through Cyviz, we have a 25G system for them in their sort of Dublin-based experience center type office. BP, we've done work with them with their One St. James Square office and their sort of webcasting studios, and also another 25G system for their control center in Norway. Boeing have used our modular matrices for signal routing for their internal testing labs, and Credit Suisse, the same product again, used in their auditorium in their Canary Wharf office. For EY, they've got a 25G powering their customer collaboration center. Very similar system over at KPMG with their U Collaborate system. Google, we've worked with for a while now with their UX labs, and we also used to be on their TechTalk design, although they've gone a new direction there. And with VMware, we have a standard AV design that they're very happy with. So if we go on to AV over IP and start focusing on this. And yeah, maybe I'll put this over to you, Lee.
Cheers, sir. Thank you. So, you know, we as a cabling manufacturer, for us, it's all about how do we deliver information, and that information can be delivered over, you know, standard local area network cabling. Could be lighting, could be HVAC controls, sensor technology, access control, and of course, you know, the growing demand on AV. Now, traditionally, a lot of AV systems use proprietary cabling systems, but we're seeing things largely now move over to what we call integrated and connected networks. And the big thing for us is about all of these proprietary cables going into a building. It does sort of introduce more cost. We might have 5, 6 different contractors on site designing and installing proprietary cabling systems to be able to deliver the need for the building. But what we're able to do is we're able to deliver that all over one cabling type, such as category 6A. Now, the big thing of these is really thinking about it. We have a new regulation in Europe that came in a while ago about CPR compliance. It's the construction products regulations, and it's all to do with fire safety of the cables. All of Siemon cables for category 6A, category 7, and even previous cables are all now CPR compliant, so they meet the latest European safety requirements. Now, the question is, some of these other cables may not. For example, we occasionally may see coaxial cable being used. Well, coaxial cable normally has a PE of polyethylene jacket, and that cannot enter a building greater than 2 meters. So, you know, it's all about fire safety. So we've taken a very strong approach in terms of ensuring that our cables meet all of the latest requirements, but they're able to deliver more than just one proprietary service. You know, if we're talking about AV over IP, the control language is IP. So the way that we've tried to do this and work differently is we talk about a digital approach using things that we call zone enclosures. So we run cables to zones or clusters within the building space. And in reality, we don't really care what those devices are going to be used or what devices are going to be connected back to the IP network, because the IP network will work in the language that that end device sees. And then what this does means that we can bring all of those proprietary solutions, cabling solutions onto one common platform. They now use one common language, and it means that the speed of deployment is much faster and it's much more efficient. And the beauty of it is that if you ever decide that you want to remove a sensor or move an AV, instead of having to run new cables, we literally go back to our zone enclosure and we plug in a patch cord or a plug link, and then we can get those devices up and running. So the whole idea is it makes things really, really easy. Over to you, Felix.
Yeah, thanks, Lee. So yeah, we're talking about sending video over a twisted pair cable, like a cat cable. There's different technologies that are being used nowadays. There were some that predate these that had their own issues, but I won't touch on those. Well, I'd say at the moment, one of the biggest standards out there is HD-Base-T. HD-Base-T is basically a modified 10 gigabit Ethernet chip, and it's designed to send uncompressed video in a point-to-point scenario. And it also has what they call 5-play, which is 5 different signal formats that you're sending through the cable. So you've got the uncompressed HDMI video, you've got the embedded audio channel, you've also got a sort of virtual 10 over 100 Ethernet channel, you've got the RS-232 and IR control channels as well. the key with HC-Base-T is the other bit of the 5-play, which I forgot to mention, is the 100 watts of power. So you're also sending power down there. Yeah, and one of the key points with HC-Base-T is it's designed to be point to point. Effectively, what they do is they take a standard IP packet and take out the address part, which gives them more room for the payload and allows them to send that signal uncompressed. And then we've also got HC-Base-T IP. So this was a development that HC-Base-T undertook to essentially put back in that address so that you could send it over an Ethernet network, although I haven't seen any development on that myself. I know with HC-Base-T 3, there is still a point-to-point system, although it's going to higher and higher bandwidths, which is kind of impressive. Then generically, AV over IP, I classify as a signal which is, encoding a raw HDMI or DisplayPort or sort of native video signal into an IP format so that you can send it over an IP network. So you have an encoder and a decoder at either end of the channel, and there's different codecs for encoding and decoding. Some are proprietary, some are open source. So with Netflix and you're streaming it to your smart TV, it's going to be something like H.264 or H.265. But then you might have dedicated devices that use JPEG 2000. And yeah, there's a wide range out there, and there's kind of a sort of battle to create this new standard that's open that everyone uses. And what seems to be very strong in that particular arena is SDVoE, which is software-defined video over Ethernet, which is a technology designed by Activision. And the key with SDVoE is it's also 10 gigabit Ethernet. It does use a light compression algorithm, which is visually lossless. So whether you'll be able to see the difference in quality is up for debate, let's say. It also gives you that 1 gig Ethernet link as well, and by using the compression, they can make everything fit within the standard IP packet, which allows you to include that IP address, which means that you can send it over your network switch. So in terms of sending video over IP or over twisted pair cabling, as I mentioned, there's been many technologies that have predated this, and generally they had a sort of mixed level of efficiency or effectiveness. What I'd say is that a lot of the time it's always come down to the quality of the cat cabling that you use. I personally supported many deployments where at the end of the day, the issue came down to they were trying to send a video signal over a twisted pair cable, which was not designed and not rated to handle the amount of bandwidth that they were trying to send over it. In recent years, the IP encoding technology has really improved. You're still going to get compression, which represents a loss in quality. You're still going to have latency, but those factors are really becoming quite minimal now, and the benefits that you get out of that in terms of flexibility of deployment and the sort of use things that you can do that you couldn't do before. It's a trade-off that is being made more and more nowadays. Here we just have a sort of brief technical comparison between all of the different standards I mentioned. HC-Base-T, the most widely used version is HC-Base-T 1, which is equivalent to HDMI 1.4. So you can get 4K through that uncompressed, but it's only 30 hertz, or you have to use the 420 color space encoding, which you could see as a kind of compression. you can use it over Cat 5e, but I would not recommend that. I'd say you want Cat 6a definitely for reasons that we'll go into. It's one of those situations where it may work on one day, but then something will happen, someone will come into the environment or something will change and then it'll stop working and there's nothing you can do. Yeah, on the other side of the equation, we've got SDVOE, which is going through an interesting time right now. There is the sort of ASIC chips are being released, which is taking the technology and turning it into a single chip or one or two chip solution rather than it being an expensive FPGA solution. So I really feel like SDVOE is going to be coming into its own very soon with the release of these new chips.
If I can just interject, if you just
no problem.
It's just really interesting there, because we as a cabling manufacturer, we still see lots of AV companies talking about installing category 6 and category 5e, and thinking about using UTP cables, which we're going to come on to a bit later. But do you see because of having zero loss being really important in terms of AV quality, do you really see that there's much loss or effect caused on Cat 5e and the Cat 6 for these higher sort of definitions?
There definitely can be. I think it's a question of what sort of level do you want to go to? Do you want something that works 60% of the time? Do you want something that works 70% of the time? Or do you want something that works 99.99% of the time? And I think a lot of integrators might get fooled into, they've done a deployment, they've used Cat 5e, they didn't experience any problems, so they think, okay, that kind of worked, and I didn't have any problems, so it's okay for me to do that again. And they'll do another deployment, but very quickly they'll run into these problems that, it's not like you'll try and turn everything on and it just doesn't work. You'll turn everything on, it'll be working for a few hours, then it'll start dropping out, then it'll go back to normal, and that sort of intermittent problem really loses, makes people lose confidence in the whole thing. And that's with AV particularly, 2 or 3 seconds of dropout at the wrong time can really undermine the whole system. So it's really a very false economy. It's I don't recommend it. Basically, I've been on site enough times with exactly the same problem to be able to say, yeah, you need to use the right cabling. If you're thinking about trying to save money on the cabling, then yeah, I would advise against that. I think having the right quality cabling for what you're trying to do is going to eliminate the majority of the problems you're going to experience.
Okay, thank you.
Oh, no worries.
So technical standards, in terms of cabling, it's really, really important. So Siemon, we do a whole host of things. We actually are heavily involved in the creation of the technical standards, both at a European and international level. So we drive ISO 11801. Some of our engineers are actually the editors of ISO 11801 for the connectivity, and I'm a contributor into the British and the European standards, etc. One of the big ones is when we start talking about this sort of stuff and thinking about where we want to be, the real issue is, how do we want our building to work over the length? So the standard sort of limit really for sort of IP technology, everything down to 100 meters, and we got 10 meters of patch cords, and we've got 4 connector links that we can pull in. But what we found is with Siemon cabling, we can actually extend sometimes some of those links well beyond 100 meters. It all depends on how the switching or the matrices are used to be able to send that data from point A to point B. But regardless of the 100-meter rule that everybody in sort of the structured cabling world would understand, is actually realizing that the standards are actually saying, if you're going to design a building today and you want this building to last, you really should be designing a building So the infrastructure is going to last for a minimum of 20 years. And this is called out by the international standards and the European standards. And actually, just going back to what Felix was saying, you know, about the issues, sometimes it will work, sometimes it won't with category 5E or category 6. The issue is it's about building the right road. Do we want that road to be good enough to be able to support that Ferrari of data transfer for 20 years? And the reality is, I use this analogy a bit like Guernsey. I don't know if anybody's ever been to Guernsey, but there's lots of people who go there for tax exile, I guess, and they have all their Ferraris and their posh Porsches, but the national speed limit, I think, is 20 miles an hour. And what we don't want to do in our world is have an AV system that's like a Ferrari and then stick it on a road that's not going to be able to support it. So it's really important that we think about following those technical standards and making sure that everything's going to work. What we've seen in the last year from Siemon, we've seen a change in some of the standards in the way that we work, and we've now brought out a thing called a modular plug terminated link. It's a new style of link, but effectively this is a direct attached cord. So the installer will be able to take a Siemon category 6A cable, category 7 cable, and they will actually be able to put an RJ45 connector straight on. It reduces the losses of a connector, and then you'll be able to plug directly into the device, making the whole infrastructure much easier to deploy. So the simplest way to do it, if we start thinking about how we deploy structured cabling, is we have to test it. So normally we would have a copper field tester, and at one end we'll have a patch panel with a connector. We would normally run that out all the way to the end to another patch panel, and then we would have a patch cord which would plug from that connector into that device. What we've actually realized is if we use the MTPL, we're able to put a physical RJ45 plug, not a connector on the end, and plug directly into that end device. And it's going to totally simplify the deployment of certain specific applications. And a whole series of tests have now been approved, so we're able to do that, and you're able to receive a standard Siemon warranty based on the application. So talking about the MTPL test, the real thing is looking at how we terminate an RJ45. Now, traditionally on category 5E, it was very easy. Everybody just took the wires, they straightened them, they put them in, they terminated it. With the birth of category 6, the copper conductors had to increase in size to deal with a higher frequency. And we really saw like the end of the RJ45 field termination plug. What we've been able to do in Siemon is actually redesign that and actually come out now with a very easy to terminate process where you still get all of that high performance of 10 gigabit Ethernet in a very, very simple to terminate RJ45 plug. So the plug goes in, the connectors go in, the shielded solution goes over the top. We don't support a continuity, we support a fully shielded 360-degree connector. That's the plug terminated, and that plug can now be plugged into any device, and it will still guarantee, if the switch or the device is able to deliver it, 10 gigabit Ethernet for up to 20 years. So two connection models, what we have here is the MPTL plug will connect directly to the device, and it eliminates additional cost, such as service outlets and patch cords. It also means that we remove disconnection points. So if we look at the AV description on the right hand side there, we can see a modulated plug being connected straight into the display. Yeah. It saves us connectors, it saves us patch cords. And sometimes where some of these devices are actually used, people can gain access to patch cords and disconnect things just because they want to. The beauty of this is everything can be just connected, terminated, and it literally just works really compliant. But the beauty of it is you will be CPR compliant, which is a legal requirement. If you want to move to beyond that, we can, if you want to, directly move into a 3 connector model. And this is where we're going to have up in the ceiling a zone enclosure where we'll have an outlet, and then we can make a solid cord connection literally from the digital display directly back into the zone enclosure, so we have as much flexibility as we want. And again, people don't have access to it. So again, it's literally going to move out connectors, it's going to move out patch cords. But the beauty of going to this model is we can then have flexibility without having to rerun cable for the movement of a new AV device. We've got the portage there, we just plug it in, we connect it, and we can plug it into the active equipment. Back to you, Felix.
Thanks, Lee. Yeah, here I just wanted to take a closer look of what you might find inside a DVI or HDMI cable, and just so we can make a comparison with a twisted pair cable. So we've got the 4 TMDS lanes. So these are the most important in your DVI or HDMI cable. They're effectively where the red, green, and blue information is sent along with the clock. So that's why we've got 4. And these are quite high bandwidth. They're unidirectional. And just as an example, for HDMI 4, you might be looking at a 300 megahertz pixel clock. And now with HDMI 2, you're looking at 600 megahertz. So it's quite high frequency. And you know, with your red, green, and blue channels, you might be anywhere between 4, 5, or 6 gigabits per second on each channel. Then we've also got the 2-wire or the twisted pair display data channel bus. So this is a low-speed channel for bidirectional communication. This is where you have your EDID and HDCP communication. So this is where your source device can ask the display, you know, what are your capabilities, or if you're using HDCP encryption, it's where the encryption communication can happen as well. Then we've got our power 5-volt and hot plug cable. So these are physical layer electrical signals which let the different devices know that something's physically connected. So when the display device sees the power 5-volt, it knows physically that there's a source device connected. When the source device sees the hot plug signal, it knows that a display device is physically connected, and that it can sort of initiate the transmission. We've got the CEC wire, which is the Consumer Electronics Control. So this started off as, you know, if you bought a Samsung TV and you bought a Samsung Blu-ray player, then, you know, when you turn on the Blu-ray player, it can automatically turn on the TV. For a long time, this wasn't really used so much because everyone came out with their own independent control protocol, and there wasn't much standardization. However, now we really see this coming back into play. There's a lot more use out of this. People have gotten onto the fact that we don't have to run a separate control cable or control interface. We can just use the one that's built into the HDMI cable. Then we've got a ground wire. And here we had a reserved wire. In HDMI 1.4, they found a use for this. And what they did was they actually made a twisted pair between this reserved wire and the hot plug wire, and that was then used to handle the HDMI Ethernet channel. So within your HDMI cable now, there is the ability for a 100 megabit Ethernet channel to connect different devices. And as you'll notice, the 4 TMDS wire pairs are all individually shielded. The DDC channel is shielded, and then the whole cable itself is shielded as well. One of the with these type of cables, the American wire gauge is often used, and with that measurement, a lower value means a thicker cable. And a thicker cable with respect to transmitting video is better because you're going to have less attenuation. You'll be able to go further distances. One of the biggest misconceptions about DVI and HDMI is that there's somehow a separate channel for the audio, like a separate wire pair or anything. That's not the case. The audio information is actually embedded in the video signal itself. So there's no separate wire for audio. So having looked at that, if we take a look at the structure of different cadex cables, you can see that the one that best approximates the DVR HDMI cable is SFTP, where we have the shielding for the individual wire pairs, and then we also have the overall shielding. If you don't shield the wire pairs from each other, you can get crosstalk and you know, different effects from that, which is not ideal if you're sending an AV signal down your cadex cable. Just to look at the importance of shielding, here we can see, on the left-hand side, we've got our original signal. On the right-hand side, we've got the signal at the other end of the cable. You can see that it's attenuated, there's less amplitude, but it's still recognizable as the same signal. Let's say someone comes into the room with a mobile phone and they receive a call, and that mobile phone starts broadcasting on its radio frequency. That signal can be picked up by anything metallic in the room. Everything metal is essentially an antenna of some kind, and that can disrupt the signal, and now you can see we can't recover that original signal. It could be a mobile phone, it could be a digital radio microphone, it could be an air conditioning unit, it could be an electric motor for a projector hoist. We even had one case where it was someone's fridge that did this. So it could be a lot of different devices can emit this radio frequency interference. So the key is, if we shield the cable, due to the Faraday cage effect, the radio frequency interference is not going to penetrate the cable and induce anything on the wire pairs. And here we just take a look at the some of the different specifications of different cadex cables. And as I was mentioning before, with HDMI 1.4, we had a pixel clock frequency of 300 megahertz, and you can see that Cat6 cables aren't actually rated up to that frequency. So it's really important that you use a Cat cable that is rated at the frequency of the signal that you're trying to send through it. So here's where Cat6A and above is that's one of the key reasons why we recommend that, along with the shielding standards as well. So traditionally, with cadex cables and sending DVI and HMI signals to them, there were some drawbacks. There could be unreliability issues, which can be from lack of shielding, or potentially going through lots of different patches. Every copper to copper connection is going to create reflections and degrade the signal. Because the cables are so thin, there can be high attenuation, particularly if you're just sending a raw AV signal through it and you're not using some of the technology we have now, like SDVOE or HDBaseT. If there's no shielding, they can be sensitive to noise. And there's also this the fact that there's different twist ratios. They do this as part of the Ethernet standard to decrease crosstalk, but from a video perspective, it can increase the interpair skew. Let's say you've got your red, green, and blue channels. If the red channel is traveling down a cable that's, because of the different twist ratio, physically it's 10 centimeters longer, that's going to create a huge amount of skew. However, we can get around this by using these AV over IP technologies, which are taking the traditional AV signal and presenting it on the cable as an IP Ethernet format, which is what the cable is designed for. Some of the advantages: they're very easy to work with. You can terminate them yourself. They can be quite cost effective. And I'd say the biggest one is, a lot of the time they're already physically installed in the building. And there's a huge history of people installing Cat cables in buildings, and there's massive standards behind it that are very reliable. So you can really build off the back of that. Let's go over to you, Lee.
Thank you. So why shielded cabling? Well, I've got to be honest, there was a great example there about UTP cabling from Felix and external noise affecting the cable. A company called GHMT in Germany, which is probably one of the world's most advanced sort of electromagnetic interference sort of test houses, did a huge study onto the differences between UTP and shielded cables. And they could actually, and on one of their reports, they actually said that one mobile phone can totally disrupt a UTP network. but they actually found that going into their hermetically sealed rooms where they were testing the cable, they could put multiple radios and mobile phones directly onto shielded cable, and because of the Faraday cage, no effect was happening. So GHMT in Germany really saw the benefit of shielded cables. And I'm a great believer, you buy German cars because they're reliable. And the German market has been using shielded cables for many years. The shielded cabling has really sort of taken over into the market today, and really now is a mainstay of cabling systems that are put into the market. So some of the primary sort of designs today, and we hear lots of discussions about different types of shielded cables. There's a cable known as an FUTP, which has a foil that sits around the unshielded pairs, stops any unwanted noise coming into the cable. We have FFTP, or we have the Arnold Schwarzenegger of the cabling world, which is the SFTP, which has got a Faraday cage, and then each pair is individually protected against transmission of noise both within the cable and something called alien crosstalk, where other cables are actually affecting the cables. These cables really offer a very small level of delay skew, which, if you think about it for video transmission, it really means that we get that picture quality, we get that data transfer there first time, and we get it right first time. So we're not going to see any sort of retransmission, and we're not going to see any sort of issues where everything is becoming slightly bigger. Now, one of the big things is, about what do we recommend, either category 6A or category 7A cabling solutions. That's really down to your design requirements. We at Siemon and our technical team and our technical consultants can sit down with you, and we can understand, what is going to be the right solution for what you really need. But the beauty of it is that if we start looking at using these solutions, we've got a 400-meter reach for IP-based controls with PoE. And what we've also seen is that the data with AV applications, we're approaching distances pretty close to 170 meters. So there's real benefit of using these shielded cables in terms of how they perform. Now, one other thing about PoE and the growth of PoE is we are injecting power up to 100 watts into our cabling solution, still delivering that 10G base T. But as we're delivering heat, we're actually seeing that there is a potential for heat buildup. The IEEE has done a lot of studies with Siemon, and we've actually found out that shielded cables dissipate heat much faster, much greater than any UTP cable. So it's about reducing heat. Now, one of the most interesting things is that if we introduce heat into a cable, and a cable goes through some sort of temperature change, we might have to derate the length of that cable to guarantee that Ethernet performance. The beauty of working with Siemon category 6A and category 7 solutions is we don't have to derate them. They've been designed in such a way that they're going to be there. And the big thing is, one cable supports every application that you may want to put onto your network. So a lot of benefits working for that. So Lightware have very kindly taken our cables. They've taken them, they've tested them, and the question is about error-free transmission. And what we found was that if we were supporting category 6A with an FUTP cable at 4K at 30 Hertz, no errors recorded up to 95 meters. And bear in mind, we've still got to add patch cords to this, so there's no issues. If we were literally delivering, say, 1080p at 60 Hertz, we can support up to 150 meters, and for category 7, 96 meters and 156 meters. And these were just using 2 standard cables. We haven't really gone into the real high advanced cables like a 1200 megahertz cable, which will be able to outperform even greater. But if you think about it, really where we're trying to do everything in that zone cabling solution, you really want to make sure that that roadway is able to support that Ferrari that's coming out of Lightware in terms of switching technology and AV distribution. So the cabling is so critical to be able to support it. So why do we do it? Well, number one is to eliminate what we call alien crosstalk. real life sort of shows us that when we take cables, we typically bundle them together, and we bundle them in either, you know, bundles of 24 cables, or some people go beyond it. And what we've seen is, as the frequency level has increased in terms of the cable, so from a category 5E running at 100 megahertz, a category 6 cable running at 250 megahertz, before jumping to 500 megahertz for category 6A, something called skin effect occurs, and it becomes a little bit harder to control the signal. So what you would have noticed, from a category 5E to a category 6 cable, the cables got bigger. They got the American AWG size changed, because we had to protect the transfer of that data, and that's done by the twisting of the pairs, and it's done by shielding, and it's done by a whole host of things. But what we found was, we started seeing where one cable had the potential to affect another cable. So manufacturers really had to come up with a way that we could stop nearing crosstalk occurring, because we didn't want any of that data at a point of launch or a point of receive actually losing any of its data transmission quality. Yeah. So we've talked about heat rise, we've talked about AV requirements, and we've talked about signal losses. All of these things affect the cables, and Siemon have done a market leading job in really developing our cables to be able to support the AV industry. And in truth, we did this many years ago for a very small company called the BBC, where we developed a 1200 megahertz cable for them, because they were looking at high definition transfer of data for their TV signals. So category 6A, we're moving towards 170 meters if we're using a 1200 megahertz connection. Industry standards should always be followed for any AV over IP twisted pair application. You know, point-to-point connections are not really standards compliant, but if you think about it now, with the MTPL, that's now been tested and that is approved, and we can prove the test data that that's going to support 10 gigabit transfer applications for up to 20 years. The use of zone cabling in terms of design, and it's not just for the AV, it's for the whole building, offers the end user much easier moves, adds and changes. They're able to make up their own short custom length runs from a zone enclosure to multiple end devices, and it saves a huge amount of money in terms of installation cost, electrical power distribution, because we're going to be running things over PoE. High performance category 6A cable is recommended, and Lightware have tested it, and they support us, so that's really, really good. And it's really about supporting the best choice, that best roadway for the AV solutions. Okay, and what we also realized was that the way that PoE works is we have a switch that's going to deliver power over Ethernet, but we plug into the switch with a cord, but it will not deliver power until it's plugged into a device, and then that device says, I need power to operate, and then that tells the switch to deliver the power. But the issue with it is we're unable to effectively turn off that power if we have to disconnect the connection. So one of the issues that we're trying to deal with at the moment is trying to work out, if we were to disconnect a connector whilst under load, could it create a potential arc? And the answer is yes, and that can actually damage connectivity. So Siemon, we've designed the way that all of the interfaces work within an RJ45 and with the connector itself. So if an arc was to occur, the arc would occur away from the connection point of the data, and that means that we can then still ensure, give you that application's warranty for 20 years that it's going to work. Go back to you, Felix.
Yeah, thanks, Lee. Yeah, I think we've kind of touched on all of the bits that I wanted to, and yeah, I guess, you know, the Cat6a part's pretty important. I mean, if you get a Lightware HC-based device, it says recommended to use Cat6a on the box. So hopefully people follow that recommendation. But yeah, sometimes that's not always what happens. But yeah, I think maybe now we can got about 5 minutes left. We can go over to some of the questions.
Thank you very much, gents. Thank you for your presentation. We have actually had quite a number of questions coming in. Thank you to everyone who's joined us today and for your participation. So a good first question that's coming is, how is the AV industry reacting to the use of structured cabling? Has there been any resistance to this?
There was initially, but I think the sort of tide has changed, and it's really, that is the direction it's going in. As I said earlier, the sort of the cost benefit trade-off of the using AV over IP and making full use of that structured cabling has really gone in that direction. I mean, in the past, you would potentially be running your own cabling point-to-point setup just for the AV, just so you know that you have control over those cables and you know what's going on there. And there was also an issue with a lot of the cable testing devices were based on the sort of Ethernet IP sort of format and didn't necessarily apply to what some of the AV devices were doing. But now that that's sort of converged a bit more, there's a lot of momentum in that direction, definitely.
Excellent. We've had another question that's come in. How widespread is the introduction of single mode fiber? We're finding with the drop in cost of SFP and SFP plus, we are putting more single mode fiber for backbone and 12 gigabit SDI signal in parallel with IP. Are we going to, they've actually extended that. Are we going to see more SFP plus and beyond on AV equipment?
I would say potentially. I think with my experience with single mode fiber is it's more heavily used in the broadcast industry, and there's a sort of historical background there, and it also favors SDI signals. SDI is a serial digital interface, so you effectively have one channel that you're using. Whereas with something like HDMI or DisplayPort, you've got the 3 color channels and the clock channel, and you want to multiplex all of those onto the same fiber. So a lot of the sort of traditional AV fiber chipsets have been multi-mode. We are seeing a broader range now, but I think in terms of HDMI 2.0 or DisplayPort over fiber, there's a wider range of multi-mode chipsets. However, having said that, there's also a wider range of AV over IP devices that have SFP modules that effectively give the end user a choice of what fiber they want to use.
Okay, excellent. Lee, there's actually a question that's coming around the MPTL configuration. So the question is the MPTL suggested as being the de facto configuration, so the 2 or 3 connections?
It all depends on the layout of the building, and that's why it's really important that I guess we all sit down to try and work out how that building is going to be used. But we also need to think about how that building is going to be used in 10 years time, not just for today. So the MTPL is a great connector for direct connection. It can run directly from the panel directly to the end device, such as the AV screen, and that's great. But what happens if we decide in 2 years time that we want to relocate, move things around in the office, and then we might have then a cable that's just sitting there not doing anything, and moving to a 3 connector model with zone enclosures gives us a lot more flexibility to be able to respond to the dynamic needs of that building as it develops. So there's not a right or a wrong answer. It literally goes back to that design question. What do we need this building to do today? What do we think this building may need to do in 5 years time? And that's a really hard question. But if you talk to a lot of the IT sort of departments, they already have like an IT plan for 5 years ahead. So it's really important that designers, construction, everybody does sit down with the IT and the AV and say, these are the changes that we're seeing. We're seeing a massive change in terms of the AV technology, so everything's got to be able to migrate and be able to move as flexibly as we can, but without having huge cost impacts back to the building. So it's yes, both will work, but it's about that design requirement for the building.
Excellent. We've actually had a few more questions come in. Thank you everyone for sending these through. So Felix, this potentially is one for you, maybe even for you, Lee, as well. So someone's questioned around whether HD-based can be supported up to 170 meters.
Yes, so that's actually using the Lightwear long reach firmware. So we have our own HD-based transmission mode called long reach. Effectively, we're halving the clock signal, which limits the resolution up to 1080p 60, so full HD. But this is where, by halving the clock frequency, we can achieve those longer distance. It also changes the frequency of noise that the signal is affected by. So I've definitely seen some cases where there's been external noise which prevents the normal HD-based signal being transmitted, but by using the long reach firmware, you can get a stable signal. And I've also seen further than 170 meters as well, but that's kind of that was a non-standard application. Let's put it that way.
So, we've had another question in here. So, with shielded cabling, grounding can be a challenge. Would this challenge not outweigh the benefit? Lee, that's probably one for you.
Well, I always I like these questions about grounding and grounding being a challenge. The under the electrical codes of virtually every country in the world, all metallic enclosures, so a rack or a cabinet, they have to be grounded. And in fact, UTP channels have to be grounded, but no one's ever really followed the instructions from the electrical industry. So everything has to be grounded. That's number one. All frames have to be grounded, and that should happen naturally. So grounding out of a shielded patch panel takes no time at all. It doesn't add any complexity to the design, because this should be happening for many, many years already. But it is amazing, though, how often we do see that installations have taken place where people haven't done grounding properly or effectively. And we're always able to help and give advice to customers on that subject. But it doesn't add to the complexity, and it does make for a more secure system. And one of the other things is about unwanted noise. If you get unwanted noise, we've got to get rid of it. So grounding out, whether it's UTP or shielded, is the way to go. Shielded works much more effectively at taking away unwanted transmission noise and taking it to ground, so it doesn't affect data quality. And of course, there's safety aspects of grounding for individuals as well that need to be applied.
Thank you, gents. I mean, we're slightly over time, but we've actually had a couple of excellent questions come in. So if everyone will bear with us, I just would like to ask you guys these because they are excellent. Yeah. So we've actually had another one come in. So someone's just mentioned, I think I read somewhere recently that Cat 7, 7A is based on European standards, and that in America they're moving on straight to Cat 8 cabling. Is that true? And what is the story behind it?
Oh, I like that. That's a great question. So it's all very interesting. So the North American standards, if you think about it, really just affect North America. The international standards affect effectively the rest of the world. So the category 7 was fully standards ratified, I think from memory it was 1992, by the International Standards Committee. So it's fully ratified. What was really sort of interesting was that there was a jump from category, we had category 6 that was operating at 250 megahertz, and then we had category 7 cable that was operating at a much higher frequency rate, and now actually going up to 1000 megahertz and 1200 megahertz. And the Americans said they didn't see a need for it. What is really interesting is that the Siemon company, which is an American company, was the pioneers, the first to market global leader of category 7. And then we saw sort of a change where they then wanted to bring in a different performance cable running at 500 megahertz. So they sort of had a real sort of issue about what they wanted to call it. So in the end, that it was called Category 6A or augmented Category 6A, for want of a better word. Category 8 does exist. Category 8 is really more for the data center environment. Category 8 delivers up to 40 gigabit over copper, but that has a much greater reduced running distance, but really designed for high data transfer in the data center, not really out to the desk. Haven't thought about that though for AV, and if there is a requirement for 40 gigabit and over shorter distances, then Category 8 could work for that. But the important thing to point out that is largely based on Siemon Category 7 technology. And when we were looking at reclassifying our Terra connectivity, our Category 7 connectors, we didn't have to go through any more redevelopment. We took a connector that we had ratified back in 1992, we took it back into the market for testing, and it was categorized beyond 2 gigahertz without any additional engineering. So Siemon are very fortunate that we did launch probably the highest performing connector in the world still today, back in 1992 for Category 7.
Excellent. And then we have one final question, and then we can close. So someone's asked a really, an interesting question here. So they've said RJ45 was never designed for today's high data rates and range of environments. They are not sealed from moisture and dust, over time tarnish and corrode. With each generation, high bandwidth copper endpoint cables are becoming more sensitive to damage from flexing and handling, i.e. Cat5, Cat6, Cat, whatever you would like to think of. And they've asked the question, is there a modern cable and connector that can avoid these limitations, or will we see fiber everywhere? Excellent question, whoever's asked that. Thank you very much.
That's a great question. So the first point is we don't guarantee the product per se, we guarantee the application. So if that infrastructure is designed to support, say, 10 gigabit Ethernet as an application, we warranty that for 20 years. So we're not warranting we obviously warrant the connector and the cable, but it's really all about the connectivity. Now, the environments in where we've seen some form of corrosion happening is where the installer hasn't, or the end user hasn't thought about the environment in which they're installing into. So we have a full suite of what we call ruggedized solutions, which offer that additional protection to stop moisture and things affecting the cable. But I've only ever seen problems with cable where the wrong type of cable, i.e. not ruggedized, has been put into an area where it is susceptible to environmental influences, such as being used outdoors, etc. So, but we have a full suite of products to support that, and again, fully supported by that applications warranty of 20 years.
Brilliant. Well, thank you very much, gentlemen, and thank you everyone for your questions. That was, excellent to see. And before we close, I'd just like to say a huge thank you to all of you for your participation, and for joining us on our Tech Talk today. And thank you again to Felix from Lightware for supporting us with this as well. It's been a privilege to work with you on this. We hope you found the session interesting, and we look forward to seeing you on one of our other upcoming Tech Talk series. We will be running the series again back out in 2021. We will send out a recording. I've had a couple of questions while we've been going through. We will send out a recording of today's session to you all in the coming days. And of course, if you've got any questions, any additional questions from what you've heard on today's session, please reach out to us and just let us know what requirements you're looking at or any particular headaches you're coming up against, and our teams can obviously support you and reach out. But yeah, thank you very much again. Have a great afternoon and evening, depending on where you are in the world, and have a great day.
Thanks, everyone.
Thanks, guys.